Welcome and let's solve this tricky radical expression together. I tell you, it's just so easy. Now, when you look at this, please don't try to use this to cancel this. You see that these two are the same, but we cannot cancel likewise this. Why? Because the sign or the operation here is addition and this is subtraction. You are not free to cancel out. Let me show you what to do when you see this kind of radical expression, and it's just so easy. So we begin with our solution. So to simplify this, we know too well that 42 is the same thing as 6 multiplied by 7. There is no perfect square in 42. So in that case, we can go with 6 and 7. So we are going to have, this is the same as root of 6 multiplied by 7 plus root of 6 is divided by, repeat the same here, we have root of 6 multiplied by 7 minus root of 6. Now at this point, just remember, for every root of A multiplied by B, it's always root of A multiplied by root of B. So we're going to apply this here. And if you do that, we have root of 6 multiplied by root of 7 plus root of 6 is divided by, do same here, we have root of 6 multiplied by root of 7 minus root of 6. Now, did you observe anything? You observe that root of 6 is, you see that these two are together as well as these two. Root of 6 is repeated in the two parts. So we're going to factor out for easy simplification. And to do that, we have root of 6, open a bracket, use this to divide these two. We are left with root of 7 plus, divide this, it divides itself is 1. Then do same at the denominator. We have root of 6. We have root of 7 minus 1. Now at this point, you can cancel these two because it is multiplying. So you are free to cancel out. So we are going to have root of 7 plus 1 divided by root of 7 minus 1. At this point, for you to simplify this denominator, you see that there is radical sign here. For you to simplify, and because this is an expression, we are going to rationalize. And to rationalize, we take the conjugate of this denominator. And the conjugate of this is simply to change the sign. So we are going to use the conjugate. The conjugate is root 7 plus 1. Use this conjugate to multiply the numerator and the denominator. So if you simplify, we are going to have these two are multiplying this and these two are multiplying this. So we have root of 7 plus 1. You see that they are the same. So we have it squared divided by, for this we have root of 7 minus 1 is multiplying root of 7 plus 1. Now what do? Just remember, for every A plus B squared is always equal to A squared plus 2AB plus B squared. And for every A squared minus B squared, it's always A plus B into A minus B, your difference of two squares. You see that this is of this form. Did you see this expression is of this form? And this denominator is of this form. So we're going to apply these two on this to help us to simplify. And to do that, we have root of 7 squared plus 2 multiplies root 7 multiplies 1 plus, this is 1 squared, is divided by, apply this here. See that this is of this form. So we want to bring it to this. This is A, this is B. So we're going to have root of 7 squared minus 1 squared of this form. So keep simplifying. This square we take the square root of, we have 7. Multiply this, we have 2 root 7. 1 squared gives us 1. Is divided by this, we take off, we have 7 minus, this gives us 1. Keep simplifying this, we are having 7 add 1 gives us 8 plus 2 root 7 is divided by, subtract this, we have 6. Keep simplifying. 8 divided by 6 plus 2 root 7 divided by 6. And that gives us, 2 here gives us 3 and 2 here gives us 4. So we have 4 and 3 2 here is 1, 2 is 3. So we have root 7 divided by 3. So this is the same as 4 plus root 7 divided by 3. And that gives us the simplified form of this radical expression. And I hope you really learned something. Don't forget to like this video, sharing it as algorithm to send to more people. And if you are still new, hit that subscription button. We have a lot to give to you. Thank you and see you in our next class. Bye-bye.